All right, so integration. We're going to refresh your memory on all the properties and applications of integration for the midterm. So let's start at the very beginning because there's always a good place to start. Name that movie.
Lion King.
A very good place to start. We begin with ABC. We will sing to begin with. Sound of Music?
I literally said it.
Oh,
No, I said Sound of Music.
okay.
No.
Here we go. Integration was the antiderivative, okay? That's when we went backwards. That's when we were given velocity and we were trying to find the original function, or we were given the derivative and we were trying to find the original function. There was also this symbol right here, the integral symbol, and then there were a few of these basic, very, very basic properties. The first one was the power property, the power rule. You guys remember how to do integration when there was a power there? What you had to do? Add, flip something, divide something. What do you add to the exponent? 1. You add 1 to the exponent and then you did what? Put it over the new exponent. And then there was always a what? There was always a plus c that went along with it, okay? Because these were known as indefinite integrals, okay? It was different when there were actual numbers here on the top and the bottom. That's when you actually plug them in and actually get a value, okay? Then you had this one where you basically were taking the integral of one function plus another function. Pretty much all you're doing is you're just taking the integral of each one separately, okay? Applying the power rule if you have to, but you're basically just taking every single term and applying the power rule to every single one, okay? So it's basically the integral of f of x, and you guys work with me because you know my board has been acting kind of crazy. I barely use it anymore. So, and then plus or minus whatever the integral is. Okay? Now none of these. Now none of these down here are in your reference book, but the very first one, the power rule, that is in your reference book. Okay? So you just need to know that when you have like a 3x squared plus a 2x plus a 1, you're just taking the antiderivative of every single term. Okay? Now, k was constant. If there was a number out front, y'all remember? You took it out, and then you just took the integral of the rest of whatever remained, okay? And then what is the derivative, not the derivative, the antiderivative of a constant? It's whatever it is with an x, okay? So it basically is just your constant times x. And then plus c. Okay? So, those are some of the basic ones, the very, very basic ones. Okay? We started with that. We spent like a whole day doing that, okay? We're probably going to spend about a total of 5 minutes going over this, okay? So, let's look at an example. On your desk, I want you guys to do the antiderivative of this particular function. Now, but don't erase, okay? So, remember, anytime I tell you to put it down, that does not mean erase, okay? So you got to check to see if you're right, okay? So, you would apply the power rule to every single term. You would add 1 to the exponent, so that becomes x to the what? Then, and then you divide by the new exponent, and there's still a 3 there. So that was the first term. What's the exponent here? A 1. So when you add, that's a 1, not a 0. So when you add 1, that becomes x to the second. So you divide by the new exponent, and there's still a 3 out front, which is a minus.
Excuse me, Miss Anderson.
Yes.
Could you please send Alma Garcia to the CLT?
Is she coming back?
She's going to be working on FAFSA, so we'll see how long it takes.
All right.
Thank you.
All right. And then for the last one, when you take the antiderivative of a constant, you get a what? What do you get? A 4x. So it's going to be plus a 4x, and then you cannot forget your c. So then it's 4x plus c. You got it right. Hold it up. Be proud. Be happy. Okay? Clear your boards. I want these on the whiteboards, not your desks. I want hold up your desk. Okay? Here's this one. I see a lot of you guys forgot. Now, yes, you could use ln here if it was just 1 over t. But it's 1 over t to the third power. So when that happens, a lot of y'all forgot that you could bring it up by making it negative and then taking the antiderivative of that. So when you add 1, that becomes t to the what power? Negative 2. You divide it by a negative 2, and then you have a plus c there. But you can't leave it with a negative in the exponent, so what do? You bring that down, so it becomes a 1 over negative 2, or a negative 1/2 t squared plus c. And that would have been your answer. You guys remember doing this?
Yeah.
Okay. Now, I have this at the bottom that says mention if there was a 4 on the top. If there was a 4 on the top instead, if there was a 4 on the top, then basically you still would do this problem the same way, except you basically would have a 4 as a constant on the outside. So if there was a 4 at the top, you just pull the 4 out. And then at the very end, you would just multiply by 4. You see how that works? Okay. Now let's cross our fingers without recording this. Let's just hold on recording this. Okay. Clear your boards. Let's go to the next problem. Go ahead. And then the 4 and the 2 would reduce. Yes, the 4 and the 2 would reduce. Okay? I am recording. Wonderful. Clear your desk. Here's the next one. Here's the next one. Hold it up. Let's see. Did we improve? Did we improve? Okay. Got the plus C. Okay. I think we were almost at 100% here. Okay. Oh, first time recording. We did. Yes. You guys converted this to a rational exponent, and then you took the antiderivative of that, which gave you 4 over 7. X to the 7/4 plus C. Good. Clear your boards. The last one before we kind of shift gears a little bit, okay? It could be very possible that you might be asked to do A. What does the apostrophe mean? The first derivative. So, you may be asked to find the first derivative and then find the integral as well. So I'm going to review a little bit, just a smidgen of derivatives, because I don't want you to be like, okay, I don't know how to do this. But you do, okay? So go ahead. Do A and B. If you can only do B, then only do B. All right. So this apostrophe right here does mean the derivative. It's the opposite. Where in antiderivative, we add 1. Derivative, we subtract 1. But after we brought the number down. So hold it up. Let me see what you got. For A, it should have been 3x squared minus 8 over x to the...
8 over x.
Yeah.
Well,
Come on, Miss Angie.
it's
No, I said 8 over...
minus 1 over 8x.
Same thing.
Yeah, it's just
A
okay, Tyler.
minus, I don't know if that's plus, but it should be minus. So that turns into that. So it should be 3x squared. See, that's why I'm glad you don't four, but had it flipped over my desk. Minus 8x to the negative 3. So then you turn that to a positive. That's what that should be. The antiderivative, though, we're going the other way. We add 1 and divide. So you should add x to the 4th over 4. And then, what would this one be? Oh, the second half. Minus 4 over x. Very good. Because you add 1, and that gives you a negative 1 at the top. And then you got to make a positive, bring it down. And then, of course, you can't forget your plus. Questions on using power rule, constant multiple, all those basic ones. Straight? Okay. So we're going to go forward. And antiderivative of e to the x is e to the x plus c, and then the antiderivative of 1 over x or 1 over u is equal to the ln of that variable plus c. Okay? If I recall, are these in your reference book?
Yes.
These are in your reference book, okay? So you don't have to worry about memorizing them, but you do need to know how to execute them, how to use them, okay? So these are two of those special types of rules when you're not dealing with just a function, okay? So on your boards, do this one. Shouldn't take too long. 30 seconds. I'm not even gonna pause the video. We're just gonna keep the video running. Tyler, keep going back and forth between the two. Fix it. Tyler, fix it. Fix it. 10 seconds. And hold it up in 3, 2, 1, and we got 3 ln of x plus c. Yes, because you can pull out the constant and you just have 1 over x, and then that's just 3 ln of x plus c. Okay, clear your boards. Here's the next one. Only because the folks who are absent is the only reason why I'm using this board. It's very frustrating, so you should feel lucky that I'm even recording today, folks who are watching this video to refresh their memory. All right, here's the next one. Let's go. Let's work on this one. I'm going to pause the video more. It's going to be a nice little hour and a half long video. Time going before we're trying to change it. Finding the antiderivative of this. Yeah. More seconds. All right, hold it up. Let me see. We have. What have you? And some of y'all lucked out because it was as simple as it was. But yes, don't erase. Take a look. Do not forget, this is a good trick to remember that whenever you have a monomial on the bottom, you can split it up, and then you're basically taking the antiderivative of each piece. So this one would have been 1/2. The answer would have been 1/2 e to the x plus 1/2 x plus c. Okay? And we got it? You could have wrote it as one fraction, so some of you guys did just do e to the x plus x over 2 plus c. That also works as well. Clear your desk. Okay? These are some of the special ones that we talked about. Whenever you have like a linear factor raised to a particular power, you had those. These were not in your reference booklet. When you had e raised to a linear factor, that was the antiderivative. And then when you had 1 over a linear factor, that was the antiderivative. The two at the bottom are not in your reference sheet either, but they're the ones that deal with trig as well. So, those are there. It'd be very possible that you have something like this, so I just want to make sure that you guys are good to go. So there's going to be 2 on this page. There's going to be 2 on this page, and I want you guys to do both of them on your whiteboards, okay? So 2 of them, they're going to be on your whiteboards. Let's do these 2. For the first one, hold it up. Let me see. Are we at 100%? I think we were when I first went around and looked. We should have had 1/3 e to the 3x plus 1 plus c. Very good. Now, hold on, I want to ask you to keep holding up, so I'm going to look at number 2 since we were at 100% for the first one. It was 1/3 e to the everything. Okay? Now, for the second one, I think this is where we started to differ. Come on. 1 and then plus c. Very good. Okay? And for the bottom one, this was the first situation from the last. Oh, yes, this is where we're starting to differ here. This is where we're starting to differ, okay? So put your words down on the race. Remember, it's 1/a. What's the value a? 2 times 1/n plus 1, which is 4. Then times your linear function. And then you raise it to the 4th power, and then plus c. Some of y'all forget your plus c. Don't forget your plus c. So when you multiply this, it's actually 1/8. Some of y'all have 1/12, so be careful. Okay? So you got 1/12 and then the rest of that. Oh, that's not what it says. Sorry. I was trying to correct the people who were at 12 and that shouldn't be 1/8. Okay? Questions up to here?
Oh, I have a question.
Yes.
For the first one, I put that all over 3. Is that okay?
Yes. Okay? Clear your boards. The next one that's coming up, it's always an oldie but a goodie. Good old substitution method. This was when the derivative was a part of the problem, and you had to plug in u to actually do the antiderivative, then plug it back in. So we're going to look at some examples that deal with this. Okay? And I lied. We're going to do these together. Then probably the next one you're going to be on your own. Okay? So, if you look at the first one, you can recognize that, one of these is the derivative of the other, right? Which one are we going to make u? The x squared plus the 3x. Okay, if you want to add these to your notes, you can. If you just kind of want to follow along and watch, that's fine too. When you take the derivative, what do you get? 2x plus 3, the exact same thing that's sitting in your original problem, the dx part. So when we go to plug it in, it's going to be the integral of u to the 5th. That looks like a signature. Okay. The integral of u to the 5th du. What's the antiderivative of u to the 5th? 1/6 u to the 6th plus c. But we're not going to write in a u. We're going to write in what? X squared plus the 3x. And I know everything is going together. That's why I do not like using this board. But I hope everybody can make out what I've written up there. Why is it not what? Oh my goodness, I'm jumping the gun. I apologize. It should be e to the 5th. You all were correct. Because all we do is plug it back. So it should be e to the 4th. Trace this u to the 5th. I don't know why. Questions? The next one. Okay? You have x times e to the 1 minus x squared. What would you make u? Say it again. 1 minus x squared. What's the derivative of this? It's a negative 2x. Okay? Now, do we have a negative 2x a part of our problem? No, we just have a what? An x. So we need to take this and divide by negative 2. So when we go to rewrite it, we'll have e to the u du. But what's going to be on the outside now? go ahead and do that for me? Write on your boards if you were taking notes. Finish off your notes. If you weren't taking notes, just kind of give me what the answer would be after you. The negative 1/2 came from back here when we divided by the negative 2. Because in the original problem it was just an x. So we had to get rid of that negative 2. So right now you're doing the antiderivative of the problem. When you have it, please hold it up. Good. Yes. 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 I want to give everyone a yes, so make sure everyone's good. Yes, Julio. Yes. 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 I'm missing 1, 2, 3, 4. 4 yeses. 5 yeses. Yes. 4. Yes. 3. Yes. 2. This part on the front. Or just take the antiderivative. So you just take the antiderivative to the end. What's the antiderivative to you? We have negative 1/2 e to the u plus c, and then you plug in the original u value. Which was c value. Okay, hey, let's try to keep it down, okay? Because I am, like I said, I'm stopped pressing the pause on the record video, so then you'll have that. Okay. All right. Now the one on the bottom. Okay. Finally doing one that deals with some trig. Okay. Do not forget when you have sine to the 4th x, that's the same thing as saying sine x to the 4th, just moving it to the outside. What would you make u here? No. It actually would be just
Sine x.
it'd just be sine x that you would make u. Because what's the antiderivative of sine x? So you have du equals negative cosine x.
Regular derivative is just positive.
It is positive cosine? Okay. Interesting. Yeah, I got the reference over there for you. So it's cosine x. That would be wrong. It's the other way then. Cosine. No, that doesn't sound right at all.
Because in integral, cosine to sine is positive, and then derivative sine to cosine is positive.
Okay, yeah. So it's the other way. So then that would be a positive cosine x dx. Now you would need to plug in and take the antiderivative. Go ahead and finish going off on your desk. I gave you the u and the du. You finish off the problem. Let me see you when you got it. Let me see you when you got it. Guys, do not forget when it's the indefinite integral, you need to have a plus c. You need to have a plus c. This one should have been 1/5 up to here.
Completely butchered that. Could you go over it a little bit?
Okay. Try this one on your own. All right, let me see. We have. Okay. So this is another U substitution. You should have made x squared u. So then that way du would be 2x dx. Okay? So then you would have to divide it, so it would have been 1/2 du and then x dx. So then that's 1/2 sine of u du. Does everybody see that? So the antiderivative of sine is a negative cosine. So this becomes negative 1/2 cosine of u plus c. And so then you will plug u back in for your final answer of negative 1/2.
It is. That's the derivative.
Okay? And make sure you guys that you do need to include the parentheses. Okay? You do need to include parentheses around the x squared because again, remember that you can rewrite cosine x squared, or cosine squared x is cosine x squared. So you want to make sure you distinguish that x squared is that squaring x and then you're taking the cosine. This one. Should be 1/4 2 plus x to the 4th raised to the 4th power plus c. Okay? Because you make this inside part, you make this u, and when you take the derivative of it, du becomes that 4x to the 3rd. And so then you'll just end up with u to the 3rd that you'll have to take the antiderivative of for your final answer, which is again 1/4 the quantity 2 plus x to the 4th raised to the 4th power plus c. Just real quick for this one, I want you guys to tell me, what would you make u? What would you make u here?
X to the third. X to the third minus x.
So it'd be x to the 3rd minus x, which means the derivative of this would be what? Minus 1. So what would you have to do? So multiply du by 2. So then when you take the antiderivative, it would end up being 2 du over, and then you just go take the antiderivative from there. Okay? I'm not going to work this one out. Starting to run out of time. We got 45 minutes. Let's put that like 20 slides. Okay? General solution is that's when you actually find the value of c, okay? And you'll know when you'll have to find the value of c is if they give you some type of point, okay? You'll plug in the point into the antiderivative and solve for c, okay? An example like that would be something like this. They give you the derivative, and then they tell you that on the original function when x is 1, y is 2. So then you'll be able to actually find what is the value of c. You just take the derivative, plug in the values, and then you'll have your full equation because you'll solve for c. Okay? So that's what I want you guys to do on your boards. I want you to find the derivative, not the derivative, the antiderivative of the function. Sorry if I said derivative, I meant antiderivative. So find that now. You're finding the antiderivative of the function. Find the antiderivative of the function. Find the antiderivative. So, the antiderivative, which is f of x, your original function, would be 1/2 x squared. The square root of x turns into x to the negative 1/2. Okay? So you gotta bring it up from the denominator. So when you take the antiderivative of that, you would add 1 to the exponent, which turns into a positive 1/2. And then you divide it by 1/2, which turns into a minus 4x to the 1/2. Okay? So then from this point, you will plug in x for 1 and y for 2 to find your value of c. So go ahead and do that. Plug in 1 for your value of x and solve. So for all this is non-calculator. You're finding the value of c. What's the value of c? I messed up when I wrote this. Should have been a minus plus stuff next time. Let's look at it as a minus. Is it 11 over 2 then? It's 11 over 2? Can I get confirmation?
Yes.
Okay, so c is 11 over 2. So then your function, your f, would be all of this, and instead of a c, it would be your final value. So that'd be 1/2 x squared minus 4 square root of x, turn that back to a radical, plus 11 over 2. And that's how you find your exact solution, your solution for this particular situation. Questions? All right. Then find f for this function. Finding f for this function. All right. So the antiderivative that you got was what? What was the antiderivative prior to you finding c? 1/3 x cubed minus 4 sine x, and then you have your plus c. So then from there, you will plug in 0 in for x, and then set it equal to 3. Well, the sign of 0 is what? 0. So then it would be 0 minus 0 plus c equals 3.
Why isn't it just 4 sin x since we know that cosine?
Because we're doing the antiderivative, and the antiderivative of cosine is a positive sign. So then that's the negative slope difference. So c would equal what number? 3. So then it would be plus 3. Okay? And you want to make sure, because if I recall from these types of questions and their mark schemes, is that once you find c, you actually have to write the full equation with the c plugged in. Otherwise, you don't get that final A1. Okay? Slightly tricky. Your final answer. The final answer for F. You should have had 4x to the 5/2 plus 4x to the 3/2 plus minus 9x. Should be 9. Plus 5. 9x plus 5.
Where's the 9?
The 9. When your first derivative, when you did it, your first derivative, you got what?
10x to the 3/2 plus 6x to the 1/2 plus c equals 12. So when you insert 1 for x, you get 10 plus 6 plus c equals 12. 10 plus 6.
Oh yeah, why did I do that? Jesus. I put 15 for whatever reason. So then that turns into 16. So yes, it should be, a minus 4. It should be a minus 4x at the end. All right. Question on finding the general solution. All right. Now, the definite integral. That's when you're actually finding the area underneath the curve. That's when you actually have bounds that are associated with your actual integral. This is the exact same picture that I used from your notes on integration, okay? So remember, the definite integral is when you actually have bounds and when you actually have to plug in those values. You're finding the area underneath the curve, okay? The first thing that we visited when we were doing integration or definite integrals was we looked at it graphically, geometrically. So when you see something like this, we have a graph. You see we have 2 semicircles and almost like a rectangular type shape. And if it asked you for like in part A, when it says find the integral from 0 to 4 of f of x dx, you basically were finding the area underneath the curve from 0 to 4. You guys remember doing this? And so basically you would be finding the area of this semicircle by using the formula for the area of a semicircle. Okay? You guys remember doing that? So then for B, when it says find the integral from 4 to 6 of f of x, what would you be finding the area of? That square. And because it was below the x-axis, it would end up being what? It would be a negative. Now do realize that because we don't have an actual function that's associated with this particular curve, when we find that area of that square, it would be a negative area. Yes.
So, I remember there were questions like this before where it asked like, what's the total area under? Like, at what point do we cancel out the negative and make it positive?
In something like this, it would so in like part D is going to ask you to find the area of the whole thing. Then that's when you just add the 3 individual areas. But if there's a function that's associated with it and you're just finding the area of the curve from a certain point to a certain point, when you are finding when you find those individual pieces, then yes, then you would add those 2 areas up together because the area would be the total of each. So for B, we will leave it as the negative value. Huh? The D would be whatever the sum of the 2 semicircles is along with the rectangle or the square. So I mean, off the top of my head, whatever those values are.
We treat 4 to 6 as positive. Cancel out the negative for that.
No, it would be that positive half circle plus the negative area for the square and then plus the other semicircle. Questions on this one? Okay, I'm going to kind of skip through because I still have, like I said, a good amount to go. You have these properties of definite integrals. Okay, these again, I pulled them straight from the notes that you guys took them. So you do have these in your possession. A couple of them that I do want to go over. The first one, when you have the same bound, the area is 0. Because clearly you're not covering any distance. And if they're switched, then it's basically the negation of the normal bounds. Everything else is pretty much straightforward. Okay? Questions on that? We did a few of these problems. I do want to go over these because you at least saw one of them on every quiz or every test that you took when you did integration. Okay? But it's saying that if you have the integral from 1 to 3 of a function, the area is 2, and the integral from 1 to 6 of a function, and the area is -3, you have to find the integral from 3 to 6. Okay? You have to find the area from 3 to 6. Now, you don't have any functions that are associated with it, but you do have the areas. So if you were looking at a graph, you basically know from 1 to 3, the area is a +2. And then from 1 to 6, the area was a -3. Okay? So it's almost like this. You have +2, and here you have -3. And so basically, you're looking for this little area right here. What is that value? You guys agree?
Yes.
It'll be -5 because 2 plus a particular area has to equal -3. So that value would have to be -5. Okay? Question on that? This one down here, from 0 to 2, the area is 5. From 4 to 6 is -2. From 0 to 6, it would be 7. And you have to find that one missing area from 2 to 4. Do that on your boards. Find that area. Hold it up. The area is 4. Okay. But you have several of those. Okay. You also have ones like this where it says that if they give you the area, then you have to find other things, other adjustments to it. I want you guys to do both of these, A and B, on your boards. Let's do A and B on your boards. To help you in trying to get through these two problems, well, B is nothing but applying your properties from the previous page, but that very first one, if you got stuck on what you do with the 1, then you cannot forget your fundamental theorem of calculus. That's when you take the antiderivative of the function and you plug in your top bound and subtract it from what you get when you plug in your lower bound. Okay? That's what you would have to do with that 1 in part A from the last page. Okay? So, this is how you evaluate definite integrals whenever you have your bounds. Take the antiderivative, plug in the top, plug in the bottom, and then subtract them from each other. Okay? So in this case, we would do what? Which is, what's the antiderivative? 1/3 x to the third minus 1/2 x squared. And then you would evaluate that from 0 to 1. What number do we plug in first? You will plug in 1 first, so then that'll just be nothing but 1/3 minus 1/2. And then you subtract it from what you get when you plug in your bottom bound, which is what? Which is 0. So then you'll get your answer, which will just be 1/6. Okay? I just taught you all through that one, because there's still a little bit more that I want to make sure we go over. There's a few other examples, but I'm not going to go into those. Okay? Same thing still applies. You just do the antiderivative, which we practice. That's what we spend half the period already doing, which is practicing the antiderivative, okay? And then after that, you just plug in your bounds, making sure you guys can do simple algebra. Something like this, though. You have to find the value of m such that once you do it, you get the ln of 3/2. This one I actually do want you guys to do, okay? It's done the exact same way. Find the antiderivative. Go ahead and do that on your boards. What is the antiderivative? You guys should have it by now. You said the ln of 4 minus x? Close, not quite. You're missing something. Not a 1. It's a -1. Remember, it's 1/a ln of the linear factor. A is that -1 that's in front of that x. So you have negative ln 4 minus x. That's your antiderivative. Now you have to evaluate that from -2 to m. So you plug in your top bound. When you plug in your top bound, you get ln of what? So it's going to be 6. And then you subtract it from what you get when you plug in your bottom bound. So that's going to be the ln of 4 minus m. Everyone see that? Now that should equal your area, which is ln of 3/2. Well, two negatives make a what? So this is really ln of 6 plus ln of 4 minus m. And knowing what you should know about logarithms, oh, not quite. You multiply them when they're being added. But before you do that, you see how there's a negative out front right there? You cannot multiply when there's a negative in front. So what do you do to that negative in front? Recap from natural logarithms. What do you do when there's a negative in front? I heard it. You bring it to the exponent. Good. Now you can multiply it. So this turns into the ln of 6 raised to the -1 times 4 minus m. And what is 6 raised to the -1? 1/6. So this is basically 4 minus m over 6. Is there any questions up to here? Any questions up to here? Now, again, knowing what you know about natural logarithms, when you have a natural log equal to another natural log, what happens? They cancel. So essentially, you're just left with the good old linear equation that you have to solve. 4 minus m over 6 equals 3/2. And you have to solve that for m. And then that will be your answer. Can someone... I have an answer. I need some confirmation. It is -5. Questions on something like this? The last little bit to finish up, there were the application parts where we applied it to two curves. This is pretty much when you take the top curve and subtract it from the bottom curve. In order to do that, you need to know what the graph looked like. This was done by hand and using your calculator. We took the top curve and we subtracted it from the bottom curve. And then we did the antiderivative there. Real quick, looking at your calculator, can everybody pull that out if you have it close by? Remember, this is where we went into math and went down to option 9. And it allowed us to type in all of our stuff to get a particular area between two curves. Okay? Some of y'all's calculator looked like this, so it pretty much was just filling in the template. Top curve minus the bottom curve. But for those that didn't have this feature, okay? For those that didn't have this feature, after you press the math 9, you had to type in your top curve, or you actually typed in your function, what it was after you subtracted the 2. You had to type in x, you typed in your lower bound, and then your upper bound. That's how you had to do it if yours, if you had like an older version, or if yours didn't have this special feature in your calculator. Okay? So real quick, can we find the area bounded by these two regions? You have to determine which curve is on the top, which curve is on the bottom, and on top of that, you have to figure out the bounds. I am letting you use your calculator to do this, so we can kind of get through it kind of quickly. You can always figure out where the two curves intersect by doing what? Setting them equal to each other. Y equals 3. So it would have been 3 minus the bottom function. And where do they intersect? 0 and So it'll be -1 to 3. Okay, so that'll be your integral. Pretend like there's an integral symbol out here. Actually, I'm gonna draw it in there. Okay, so this will be your integral. So then that's when you go to your calculator, you would press math 9, and then you would fill everything in. If yours is like mine, you fill everything in. If yours isn't like mine, then you would do your function, which is this whole part, comma x, comma -1, comma 3, and close it off to get your area. Make sure you include that parentheses, otherwise you're going to get something funky. Did everybody get this? We can easily convert it back to a fraction because this problem was originally meant to be a non-calculator problem, and this would have been your answer. Questions on that?
How do you tell which one's on the top?
When you graph it, basically you look to see where they intersect, and then from intersection to intersection point, you look to see which curve is on the top. And so in this case, you had, when you graphed them, your horizontal line of 3 was on top of the other one. So then it would have been x squared minus 2x. Let's hope my calculator doesn't shut down in the meantime. So you had this. And then here comes the quadratic. And as you can see here, the blue line is clearly on top of the red line from intersection to intersection. Okay. Good question. Ones like this, though, we're not going to work this one out because, we're just out of the time. But if you look, the area of the shaded region, you see how it's split up? From 0 to whatever this x value is, which curve is on the top? C1. So you would do C1 minus C2. just from 0 to that particular x value. But after that, from that x value to pi, which curve's on top? So then you would have to do basically 2 different integrals, find those 2 areas, and then add them up together. So be cautious of when ones cross each other or cross the x-axis. It does make a difference. Volume of revolution, this was another one. If it asks you to find the volume, formulas in your reference booklet, you pretty much just plug in. A lot of y'all, back in the day, you forgot about the pi. So do not forget about the pi. But it still works the same way. Square your function, take the antiderivative, plug in your bounds, multiply by pi. Linear motion, this was the whole displacement, velocity, acceleration. But it still was worked out the same way. Whenever you took the antiderivative of velocity, you were finding your displacement. And then total distance travel was another part of linear motion, which was the absolute value of velocity. This was something that we did not learn how to do by hand. So distance traveled is something that is definitely done in your calculator. Okay? Real quick, where's absolute value located? Math, and then number. So when you want to do the total distance traveled, you would go math 9, and then when it came down to time to type in your function, you would go to math and then number, and there's absolute value right there. Okay? Distance traveled is, again, still nothing but the area underneath your curve of your velocity function. So something like this, you want to find basically the area of each one of these little regions to figure that out, because there is no function. However, if there was a function such as this case, then that's when you would do the absolute value of this function, and you would evaluate it from 0 to 3. It's asking for 3 seconds of motion. And something that took us, like I said, a month and a half, we just kind of summed it up real quick in about 90 minutes. Okay? It was a lot. Hopefully, if anything, it kind of got you back thinking of like, okay, I do remember some of this. I remember where my, I do remember where some of my strong areas were, some of my weak areas. Okay? You guys do have some homework to refresh your memory on integration, all of integration. And then we'll tackle probability. Probably a different way to make sure that y'all ain't falling asleep, but probability, there was a lot there too. Okay? One of the downsides about, having a lot and trying to get through, make sure we review everything that we can.